Let's read the question. Question says, the weight of an object is 4 tons and it rests on an incline of 30 degrees to the horizontal. The coefficient of friction is 0.6 for the surface. Now you are asked to calculate the force required to pull the object upwards against the slope if the pulling force forms an angle of 20 degrees with the incline. And also you are asked to calculate the force required to push the object downwards along the slope if the pushing force forms an angle of 25 degrees with the incline. That's what we should do. Let's move to the next question. I already wrote our data. You can see we have 4 tons, but we know now tons are kgs, so we can change that tons to kgs. 1 ton is 1000 kg, so we have 4000 kgs. We are told that this angle, the 30 degrees, is the angle of the incline. That means it is theta. Then the 20 degrees is the angle of the force, that is, it is beta. We are told that we do have the coefficient of friction, which is 0.6. Now the question says we should find, it says calculate the force required to pull the object upwards against the slope if the pulling force forms an angle of 20 degrees with the incline. So I just copied this formula. Now I will do the substitution for it. Okay, remember the weight is the same as mg, so you can just write down your g. Remember, g is equal to 9.8 meters per second squared. So here we'll have mg, here we'll have mg. If you want, you can rewrite right. Then let's do the substitution. Mu is 0.6, I thought, yes. Of 20 degrees. Then you press all of that in your calculator and then you get the answer. Then you press the equal sign. So we have 34,910, comma, we have 256, but 9 is bigger than 5, so we can say 257. Round it up, 257. This is a force, so it is in newtons, but the same force you can rewrite it as kilonewtons. It's equivalent to 34,91 kilonewtons. So this will be the force that is required to pull that mess. Then let's move to the second question, because this question is in 2 parts. So in other words, this is beta 1. So let's read further. Also calculate the force required to push the object downwards along the slope if the pushing force forms an angle of 25 degrees with the incline. Now in other words, our beta 2 is 25 degrees, but this time everything changes. We are no longer going up, instead we are going down. So when we go down, what do? We change signs on those ones. You'll have negative on both of them, and this time we will actually start with sign, and then this will be the next one. What we will do next is to insert values. Theta didn't change, it's still 30. Let's go to our calculator. We have 4,000. Let me put my calculator here. Okay guys, you won't see the calculator this time. Okay, let me try to show you. So this is my calculator, and now we have that. Okay, I don't know where to put this calculator so that you may see and not have questions. It's 4,000 close the brackets, minus this time again 0.6 times 4,000 times 9,8 cos 20i, it's cos 30. Then we come to the denominator, 0.6925, close the brackets, plus it's negative cos 25, close the brackets. Okay, as you can see, the answer is just 0, 0, so I won't write those zeros, I'll only write 2 decimals. So this is the case that you can write 2 decimals after the comma. Otherwise, you have to have 3 decimals, but in this case, we can see we have 0 as the 3rd decimal. The 4th decimal is also 0, so 0 is less than 5, so you can make this 0 to be 1. You can round it up. Otherwise, you will leave it like that. So it will be 1177,99 in newtons. If you want to change it to kilonewton, you can say 1,17. This time 9 is more than 5, so we can round that's the second 7 up and make it comes 8. So this is what you will end up having as an answer for this one. I hope it does make some sense. Now, what does this imply? Obviously, it shows us that it is harder to climb up an incline than it is to go or to go with the incline, to flow with the incline. It's much easier. This is a very low, or this is a very small force compared to 34. I mean, you can see this is 34, this is 1. That's 34 kilonewtons, this is 1. So it's very, very small compared to that one. It's more than 30 times less than that one just to climb up, but this one to go down, so it's quite smaller. That's what it means. So what makes that thing to be so is because of the weight component of our block, or of our whatever thing that is being used there. What did they say? Okay, they didn't say what it is. So it's that weight. is the weight component. That is why we have to consider the weight component, the parallel weight component. So this is the parallel weight component, that Fs. That is the one that make this whole lot of difference. If we didn't have that parallel weight component, we wouldn't experience such a huge difference. So that what is implied by these different answers, and the values are quite huge.